Good day, my viewers. I welcome you to our continuation learning of chemistry education. On this channel, we look at science subject and then mathematics. What are we going to be looking at today? We are going to be looking at subject on chemistry, and the topic is on element and symbol. Element and symbol. Why do we have to look at element? What is the reason of studying element? In the last class, we talked about matter. We said that matter undergoes changes. Virtually everything in universe tends to be under what matter. Because we say that matter is anything that has mass and occupy space. I am an example of matter. Table is an example of matter. Most things, objects are the example of matter. And matter can be one form of liquid, solid, and gas. Likewise, liquid or plasma, another state of matter. Having said that, so this element is under matter. Most of the things, the substances, the material that we see around us, they comprise of one or two elements. That shows us that the importance of elements can never be overemphasized. So this is the reason why we have to study what element. Most of the things around us, like I've said earlier on, contain element. Most of the substances, the wood, the matches, anything, most of this around us, and likewise contain what element. Having said that, like we normally do on this channel, we first of all have to look at our learning objective before we go further. What our learning objective is on the board. Our learning objective, we are going to look at what is element. We are going to give example of element and the derivation of element. How do you get the symbols of this element? Because a symbol is just an abbreviation of representing elements. No two elements have the same symbol. Different elements have different symbol. Symbol of phosphorus is different from symbol of potassium. So difference of element being, whenever I see H stands for hydrogen, O stands for oxygen. That's the beauty of this symbol. Now let's take it up. What is element? If you want to define element now, you can say element is a substance which cannot be split into two or more simpler units. That's why we define element. Let's put it down. I will explain. An element, an element is a substance, which cannot, which cannot, which can, which cannot be split into two or more simpler units. Unlike what you have in compound. The compound can be broken down to give one of two or three elements. Compound contain element, but element is just a substance, one kind of matter which cannot be split into two or more simpler units. Okay, so element contain atom. If you talk of atom, you talk of element, but that's another topic for the day. We are going to look at later atoms. Atom is a topic. So we are talking about elements. So elements is very, very important. So what are the examples of element that we have? We are looking at the first one. Example of element that we have hydrogen, we have oxygen, we have nitrogen, and the rest. If you look at the periodic table, the first 20 elements, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and the rest. These are the first 20 elements, goes like that. And each one of them have what is called symbol, leading us to verifications of element symbol. Verification of element symbol. How do we get the symbol of this element? Like you said, no two elements have the same symbol. Different elements have different symbol. Okay. Now we have principle or concept which we normally use to derive the symbol of this element. The first symbol, the first concept, the first concept, that is the first principle. You can say we derive some element from the word first letter, first letter in the element. Let's put it that in the element. So the first letter in the element. What do we mean by this? If you look at example, hydrogen, hydrogen element, hydrogen started with what? H. So the first letter is what? H. Okay. If you look at oxygen, oxygen starts with what? O. O. Please, all your symbol, the first letter has to be a capital letter. We don't write each hydrogen as is. It's wrong. So write a block letter or capital letter. Symbol of carbon. Carbon started with C. Put your C there. Nitrogen. Nitrogen starts with your capital N. N like this. So the first letter is uppercase letter or capital letter like this, on and on like that. The second principle, how we get the symbol. The second principle of deriving the symbol of element. We get them from the first two letters in the elements. What do you mean by the first two letters? Example, if you look at aluminium, aluminium is an element. You will start with your Al. Symbol is what? Al. Okay? If you look at calcium, calcium starting with what? The first letter Ca. So please, the first letter is capital letter, the second letter is what? Small letter. Very, very important. Note it. Another one which can call what? We also have barium. Barium is what? Ba. You can see Ba. What about neon? Neon is what? Ne. Capital letter N, small letter E, Ne. On and on and on and on like that. So many of them. Maybe let's add another one. If you look at another, we call nickel. Another beautiful element. Nickel has symbol Ni. You can see. So that is the second set of deriving what? The symbol of a particular element. Let's look at the third principle. The third principle of deriving the symbol. Third principle. This one focus on the first letter, okay, and another letter in the element, What do you mean by that? Let's look at magnesium. Magnesium is what? Mg. Capital letter M, and then G is inside the word, the letter. What about chlorine? Chlorine is what? Cl. Capital letter C, small letter L. Cl. Okay. What about, you also have manganese. Mn. Okay. So these are some of the things we are talking about. We got them from the first letter and another letter inside the element, manganese, and the rest like that. So that's what we are saying. What about chromium? Yes, chromium. Chromium is another element. Cr. Anywhere I see Cr means what? Chromium. So that's what we are saying. So element and their symbol. That's how we call it. What about the fourth principle? The fourth set. How do you get the symbol of those? Another one. Okay, let's look at the first principle. First set, we got the symbol of some of these elements. Okay. So the fourth principle, what you are saying. Fourth principle, yeah. This one, we got their symbol from their symbols from what we call Latin name. Latin name. We use Latin name for this element. What is Latin name? Latin is the language. Most of these elements, most of these scientists that discover some of them origin, some of them have an idea of what's called the Latin. Latin is a language. So we got some element from their Latin name, their symbol from the Latin name. Example, let's look at sodium. Sodium Latin name is what? Natrium. Na. Potassium is what? Kalium. Symbol K. What about iron? Iron is ferrum. Fe. You can see. What about copper? Cuprium. Copper. Okay, let's put the copper. Copper is what? Cuprium. Latin name is Cuprium. Cu. That's what we are saying. Other ones too. We have the silver, argentum, Ag. Mercury, hydrogen, Hg, on and on like that. So this is another way of deriving the symbol of some of these elements. The first set, the first letter, the second set, the first two letter, the third category, the first letter, and then another letter inside the element, and then the fourth principle. You look at what the Latin name, get that symbol from the Latin name. I repeat, no two elements have the same symbol. Virtually, we have so many of these elements. I think we have almost 109 elements. Yes, but some of them are not stable, they are radioactive. Some. So that's why the number tends to be, they have a short lifespan. Most of them that are radioactive in nature. So with all this one, anywhere you see H, I'll be talking about hydrogen. O stands for what? Oxygen. On and on like that. So we are able to achieve our the three learning objects. We have defined this element, a substance which cannot be split into two or more simpler units. We then have what? Example of element, hydrogen, oxygen that we breathe in, nitrogen, and the rest. How do we derive the symbol of this element? You've seen the method, following four principles. So that's what we are saying. And most of these principles are based on what Berzelius. Berzelius is 1814. Tell us here. Berzelius. Berzelius in 1814. Also give out the verification of most of these early Berzelius in 1814. So that's what we are going to stop today. We have been able to see most of these elements, how they are being derived and how their symbol looks like. But no two elements have the same symbol. On that note, this is where we are going to stop today. In the next class, we are going to be looking at another very interesting topic, which we call atom, molecule, and atomicity. It's very, very interesting because atom and element are linked together. Element is atom is also under what? Elements. So on that note, this is what we are going to stop today. If you have not subscribed to my YouTube channel, kindly subscribe to my YouTube channel, Science Chem Master, so that you can be able to see all the topics we have done in either physics, chemistry, biology, and mathematics on this section. I say you should remain chemically intelligent. Bye bye.